We have an update on NASA's decision whether or not Jared Isaacman can service HST while on a tech demo for SpaceX. So let's get into it. Last month, NPR released an article about how NASA's Hubble Space Telescope is being the target of private astronaut Jared Isaacman's SpaceX technology demo. Isaacman had offered to fly himself and a crew of civilian astronauts to service the Hubble Space Telescope on his own dollar. NASA was considering the offer, but raised several concerns about the currently untested technology and while weighing the necessity of servicing HST as it is now. I covered the initial concerns in my previous video if you are interested about the specifics of that whole situation. The rest of this is just going to be follow-up to that, so context is there. So, our best friend Nell Greenfield Boyce is back. As of yesterday, NPR and NASA have both published articles about the future of HST and where we go from here. NASA's answer to the private astronaut was no. This is the result of a NASA and SpaceX joint feasibility studies that explore the possibilities of what could be done for HST. So, both of these organizations worked together to look into the realities of what can be done, could be done, and at least NASA came to the conclusion that this was not going to be feasible at this time with this specific setup. Mark Clampin, the director of Astrophysics Division of NASA's Science Mission Directorate, said that the assessment of Isaacman's offer included risks such as the premature loss of science in the case of Hubble being damaged by accident. That's a pretty significant risk, I would say, which makes sense that NASA would be concerned if that was from their studies. They decided that Hubble being damaged was a very likely cause, like a non-zero possibility in a way that was concerning. NASA officials are still claiming that HST can still perform adequate science until the mid-2030s, so a loss now would effectively lose a decade's worth of observations for the international astrophysical community. Another quote from Clampin regarding NASA's decision was, "After exploring current commercial capabilities, we are not going to pursue a reboost right now." Again, not that they're never going to do a reboost. They could still do one. There is about 10 years to decide whether that's something they wish to do. It's just, as of right now, they are not going to be going with private astronaut Jared Isaacman's proposal to do a reboost this year, I think was the proposed timeline. The project manager for the Hubble Space Telescope at Goddard Space Flight Center adds, "We do not see Hubble as being on its last legs. We do think it is a very capable observatory and poised to do exciting things." So, what does this mean for the future of Hubble, servicing-wise? The article confirms, just as the last one did, that NASA has not given up on Hubble, but we'll wait to see how HST performs over the next decade of service to determine whether a reboost is in order or some other servicing mission, including one that may help its descent into the Earth's atmosphere safely. The lifespan of the HST is something that NASA has been aware of for many years, and with the HST team entirely focused on its health and performance, I have no doubts that there are already several actionable plans that NASA has regarding the end of the telescope's life. This is me speculating here, but I firmly believe that there's probably a committee or a group of people on the HST team that have been thinking about this since launch and have been, making plans accordingly. When you plan a project like a space telescope, you do consider things like, well, what happens when it dies very early on. So this isn't new, this isn't strange information, it's not something we've never considered, but it's just part of it is see how it goes, see how long it lasts. The expectation it lives to the 2030s is there, but there's a reality that it could be longer by a little bit or shorter by a little bit. There is a level of watch what happens. I mean, it's unlikely, but it could be hit by a meteor and fall out of the sky. Who knows? Unlikely, but anything's possible. That does bring us, as much as I'm, telling you how Hubble's doing a great job, we're having a great time, there is a little bit of an issue. So everybody, this is where we're gonna get into a little bit of the drama of it. So grab your cups, grab your saucers, because it's tea time, friends. So what is the issue? What's going on? Hubble is facing a pointing issue with one of its functioning gyroscopes. So HST is installed with 6 gyroscopes that help the telescope point, with only 3 being needed to point at maximal efficiency setting. The 6 gyroscopes that are in it right now were installed during the last servicing mission to HST in 2009, and only 3 of them are currently functional. So one of the functional gyroscopes has been having issues since its installation with a saturation issue. So saturation is when the gyroscope itself is indicating that it is slewing at a maximum rate, regardless of what the rate it's actually slewing at. So what do I mean when I say slewing? Slewing is essentially when you have a telescope pointing, it moves kind of like this, you know, like it can go this way, go that way, so it can point to different parts of the sky. While it's moving, we say it's slewing. And that's just, you know, getting that angular kind of motion. And so what's happening is that one of the gyroscopes that's helping it move and point is saying like, oh, I'm moving at the fastest I can, whether it is or it's not. So it's just kind of a confusing, it's just giving you returning a false value, which is annoying. So this issue has been present for a while. In the past, the Hubble team has been able to reset the issue with, like, from a software point of view, but as of late May, apparently the issue has become more permanent. So I don't know if it's permanent necessarily, but it's one where they used to be able to fix it with software. The issue would go away, they wouldn't have to worry about it for a while, it'd come up again, they do the same thing. It seems like when they're fixing it, it's not staying fixed, so that's the issue. The solution to this problem child of a gyroscope is to change the method of pointing for HST, one that involves only 1 gyroscope at a time. So this method, according to NASA, was developed over 20 years ago specifically to have a secondary operating mode to prolong HST's life with consistent observational outputs. HST has even operated on a 2 gyro mode before, but it was found negligibly different than the 1 gyro mode, so you may as well just use 1 instead of 2. The 1 gyro method has been demonstrated before in 2008 with no impact to science observation quality, according to the NASA article. So there is a level of like confidence by switching into the 1 gyro mode, because there was a window before around 2008 where the HST team did try to focus on using less gyroscopes than 3 just to see how effective it is, what kind of losses they take. So there is data that has been taken on this already. So that's kind of, you know, adds to the confidence of switching to the different method. With HST using only a single gyroscope, the method also preserves the other fully functioning gyros so that it can take its place in the event that this first one starts having issues as well. So there is a level of it's kind of breaking it down to preserve it for longer. The other effect that comes with switching to the 1 gyro system is that the slewing process will take more time than it did before. The article did not specify how much longer it takes to slew, but I imagine it wouldn't take a significantly longer amount of time, but it will probably affect some of the observers working with HST in the future. Because when you work with a telescope, the amount of time you have on the telescope every second counts, so every extra few seconds of slewing time is going to affect how many targets you can see in a window. So, you know, there will be some effect. It might not be the most drastic effect, but we'll see how it goes. It seems like it should be fine. It seems like it'll probably be within the range of assumed difficulty. While HST can still point effectively, there will be a few limitations that come with the change in pointing. The biggest one is that the telescope is losing some flexibility as to where it can point to, meaning that it won't be able to point at anything closer to the Earth than Mars. This, from an astronomical perspective, is pretty close to the Earth and will most likely not affect the targets that most observers requesting time on HST are interested in. A lot of people who are using HST are more interested in like deep space objects, far out things, so it's not frequently used for intra-solar system, I'm like trying to think of what's between Earth and Mars that you'd want to look at. It's not really used for that very frequently, so it really won't affect many of the people using it, so it's a pretty okay loss. So, to wrap up, HST is alive and okay. As with all aging technology, parts begin to stop working as well as they used to, and this is especially the case when the technology in question is dangerously difficult to access in order to do servicing and repairs. It seems as though the next decade of HST will be business as usual, which I hope it continues that way. The NASA article also mentioned how Hubble will be working alongside JWST and the soon-to-be-launched Nancy Grace Roman Space Telescope, which by the time of writing is set to launch in May 2027. So that's exciting. I didn't know it was that soon. The Roman telescope is designed to investigate dark matter, dark energy, exoplanets, and other mysteries. It really does feel like we are living in the age of space telescopes. I was very proud of writing that line, so I had to say it. And now that I say it, it sounds cheesy. But that's fine. I'm a little bit cheesy anyway. As a secondary backup, how I think about some of this stuff. In terms of gyroscopes and telescopes, especially space telescopes, gyroscopes seem to always be the like part of the thing that's kind of like messing up. There seems to be a lot of like weird gyroscope problems. Not that I think gyroscopes are like shouldn't be used or are like, you know, too flawed, but I just do think it's interesting that gyroscopes seem to be a really big sticking point. They're so important to telescopes because they do the pointing, right? Which is, if you can't point a telescope, you really can't use it. But yeah, I think back to the Kepler mission, where Kepler had 3 gyroscopes. One blew out. They were like, that's fine, you really only need 2. The other one blew out, and then they were like, bro, okay, that's a little bit of an issue because you really need 2. But they were able to go on and get it to work using photon pressure. The story's actually kind of crazy. I mean, it might even warrant its own like video just to talk about what happened with Kepler mission, because it's very cool. It's very interesting. Like I was when I talk to other people, especially about instrumentation or space missions, people love to talk about the Kepler story because it's so like way to have everything kind of fall apart but try to like bring it back so it's still useful. And a lot of the data that Kepler found, it was mostly looking at exoplanets, was that like it found a shit ton of exoplanets. It was very effective. So there's a lot of like winging it and figuring it out on the fly that comes with space telescopes, or space missions in general, which I just find it so cool. It really, to me, it feels like very like explorer adventurer type of like, you have to think on the spot and get things figured out because you have no time, you have no second chances, and it's cool, it's exciting, it's scary, it's all of that. So you know, that's how I feel about it. That's kind of why I want to be a part of it. But yeah, and also just with slewing, with telescope slewing, it's just funny because I had in the observatory at SF State that I used to help run. We did an observatory for like general public kind of use. So not like a research observatory, but our biggest telescope, it had like an auto slew feature, which means, you know, via software you could say point to this star and it would be able to point itself. But it also had a gyroscope issue. It had like the same problem, which I think is kind of funny, where it would slew too much, or it just had a lot of slewing issues, so you'd have to manually do it, which was very difficult to do. But yeah, so it seems like gyroscopes are just an interesting sticking point. If I were not a student and I was working in research, I would probably look into potentially trying to maybe see what I would just look at a gyroscopes in general and try to be like, why are they failing? Are they all failing in the same way? Like, what's up? Just because, like, you know, it seems like a good point to try to work on improvement. But, you know, with HST, it's also interesting because we're talking about gyroscopes that are 15 years old when they were installed. Like, they've been installed for 15 years, so who knows when they were developed. You know, there's a level of, like, oldness that comes with space telescopes. The joke about space telescopes versus ground-based telescopes is that once you launch a space telescope, it's already outdated because of how long they take to build and launch, versus a ground-based telescope where you can update it as you do. You can fix it. You know, once it's done, you just plop it on the mountain and then it's there, and you know, they're a little more in date, but you do have the atmosphere to worry about. So there's like the pros and cons between both. So it's just kind of funny. But yeah, I'm excited that HST is still okay. I'm interested that they are switching to the one gyro method, but you know, we'll see how it goes. Yeah, that's my like rambling thoughts at the end. So thanks for watching. Be nice in the comments, and please check out these articles. I put all my references in the description box because don't believe me if I don't have references. Just don't. And I was going to make a video about the Voyager 1 news, but this update kind of bumped up in priority, so stick around for the Voyager 1 video. I'm excited to talk about the news there, because there's some news. I have thoughts, I have opinions, and boy oh boy, am I gonna share them. So that's on its way. Yep.